From Tonawanda, New York, please welcome Glenn Thomas from ASI.
My name is Glenn Thomas. I am the CEO of Adiabatic Solutions, or ASI for short. We are an advanced manufacturing company that produces metal components with superior performance characteristics at much lower manufacturing costs than current methods. So let's take a look at our plan. The technologies that are used today to make metal components have been around for 200 years to 2,000 years or longer. We're very familiar with lathes and mills. The core technology hasn't changed basically over that time. It's gotten incrementally better, but fundamentally it's the same technology. Today what we offer is called high-velocity impact forming. It's truly, we believe, a transforming technology, and it is 21st century. It's been developed over the last 8 years or so. HVI harnesses what's a phenomenon called adiabatic softening. It was first observed in World War II with high-velocity anti-tank rounds. When you shoot a round at 4 inches of armor, punches a clean hole in the armor, doesn't tear the armor, doesn't cut the armor, it causes this adiabatic softening phenomenon and pushes the metal into the tank. Much like a shock wave on a jet fighter going supersonic, the way it works is the high-speed impact causes a shock wave in the metal. Gives you about a millisecond to put the metal into a gel state, a huge pulse in temperature. You don't want to put so much energy in that you melt the metal. We actually put the metal in what's called the gel state, and in that short time we can push it into a die and form a part. Our press design incorporates a high-velocity ram, multiple impact axes, a proprietary tooling and punch designs to enable forming at a very high rate. We can take a metal slug like this and make a part like this at a rate of 1 per second. 1 per second. We can do the same thing with gears, other components. We change the die, you change the part. This is a picture of our machine. This is the high-speed ram. The axes of impact, there's the first axis here, second axis is a third axis that you can't see. This machine is ready to go in production in our Tonawanda facility. The components, the superior performance that we have is just one of the competitive advantages. Basically, we create breakthrough increases in part strength, 20% to 94% or higher. Why is that important? Well, if you have a lighter engine valve, lighter engine components, you have a lighter engine, you get better miles per gallon. If you have a stronger component, such as a knee or hip implant, you can have longer life, improve patient outcomes, reduce the cost of medicine. Our process creates tremendous dimensional accuracy and precision in one step. If you compare us to, for example, making a knee today, you will have a casting, and then they machine it, and then they grind it, and then they polish it. We can form that component in one step with a finished product with 1 step, 1 per second, which leads to these tremendous component savings of 50% or more on manufacturing cost. And that's not hype. We actually got our first purchase order about 2 weeks ago to make a metal component, a steel liner that's currently being machined in China by the millions, and we beat China's price by 25%, still have a 50% gross margin on the part. Significant barriers to entry for competitors. We have patents pending, a lot of trade secrets that we've held, and a lot more patents that we're going to be filing over the next 6 months. Huge potential in a variety of markets. We focused on 5 markets with a potential of about $7 billion per year. Manufacturing capacity on one machine is 10 to 25 million parts per year. Very green process. We use about 10% of the energy to get to the final state compared to conventional manufacturing processes. We don't use any coolants, so you don't have any disposal of coolants. And we don't have any contaminants, so we're not contaminating the surface of the metal, and there's no waste. We weigh out a slug of metal or a charge of powder, and that's what you get in the final part. There's no waste. It's a very versatile process. All the materials that are currently used in common components today, we can form. All kinds of steels, nickel, chrome, aluminum, brass, even the strong metals like titanium, in various forms: wire, bar stock, blank, sheet plate. Powder metals, we can also have a process for that, and I'm a co-inventor on that. Powder metals is where we get our greatest increase in strengths. We have doubled the strength of titanium alloys with powder metals. And powder metal with ceramic blends are also possible. Our game plan. A very important part of our strategy is that we're right here in Buffalo. You know, we're bullish on Buffalo. The principals of the company all have long-term Buffalo residents, and yes, we always wanted the Bills to win. Hey, some of us even remember the Cookie Gilchrist era, frankly, so we're dating ourselves. Our big game plan is to sell components. Sell components, not equipment. When we have a machine that can make 20, 25 million parts per year and pull off 10 million in margin, we can build a machine every 3 months. We don't want to sell the machines, we want to sell the parts. We think of it as we've built the golden goose, we're going to keep the golden goose, and we're going to sell the golden eggs that the golden goose lays. Part of our strategy is to partner with market leaders and various, with significant market share. We can leverage their sales force, will help us to gain market entry quicker in these markets. Great joint ventures, we're talking to some folks about doing that now in the medical field and dental field. Licensing agreements. If we are approached by or approach a large company that has significant market share, we're not against leasing the equipment and taking a royalty per part. Our tactics, we've been utilizing independent sales reps. So far, it's gotten us started. The markets that we're moving into are very well served with independent sales reps. We are, as a key hire, though, with the winnings that we have from here, we're going to hire a person for business development, vice president for business development. They'll help organize this better. And we're going to focus on applications requiring high quality and high volume. Priority customers. Our first customer, steel cases used in the energy field, millions of parts per year. Like I said, we beat prices from China by 25%. Target applications include powertrain automotive components, excuse me, small engine components, medical and dental, orthopedic components, abutments. These are pictures of abutments here. These are titanium devices that go in your mouth. They're very small. These devices sell to the dentist wholesale, $190. We can make that part for about 50 cents. Fasteners, including especially aviation, where they need the strength increases. Personal protection, body armor. We've already talked to the Army and the Marine Corps about that, and we're interested in pursuing that as well. Development goals, turbine blades, stator blades, and turbines. Since we're making parts stronger, we believe we will be able to increase the creep strength, which allows the turbines to run hotter, which will improve the efficiency of the turbine engines, get more miles per gallon. Our P&L projection, 1 year from now, we expect to have $170,000 in revenue. We can easily exceed that with our first customer, have an operating loss of about $750,000. Obviously, the winnings from here will pay for a good portion of that, if not all of it. We show growing to $52 million in revenue by year 5. The important point there is that's less than 1% of the market potential in these markets that we're going after. The markets are huge. In terms of productivity, the machine we currently have can get us into year 4, but we show in our business plan adding a second machine by the start of year 3, a third machine by the start of year 4, and 2 more machines by the start of year 5. So in year 5, we'll have 5 machines or 5 press systems running. We show adding 38 jobs to the Buffalo area by year 5. Half of those jobs are on the floor. These are not $10 an hour jobs. We have them budgeted at $25 an hour manufacturing jobs, not including the benefit. We're going to be paying our workers well. Productivity gives you that ability to do that. Our team is a veteran team. Myself, I'm the former COO at GenCore, which was owned and run by Mr. Greatbatch. I'm proud to say he's one of my mentors. Before that, I was a director of engineering at Greatbatch, 34 years of industry experience, a few patents. I've always made stuff in my career, whether it's 10 million cameras a year at Kodak or 600,000 implantable grade batteries. I've always made stuff. Our board is very complete, I think. John Mascotti, partner in Colligan Law, is one of his specialties is security law. He keeps us on the straight and narrow, or tries to anyway, John, right? Professor Mollendorf from the University of Buffalo. Professor Mollendorf is a fellow in the American Society of Mechanical Engineers. People don't know this, but his groundbreaking work done here at UB back in the 80s led to the current generation of turbine engines with their increased fuel efficiencies. That's why he's a fellow in ASME. And his contacts in the industry, we've started that process of getting into that industry. Keith Blakely, CEO of the Inventors Group, serial entrepreneur. Keith is an expert materials guy. He really is an expert materials. And his industry contacts, which are vast, led to our first purchase order. Thank you, Keith. Ted Cadwalder, the financial advisor and business development guru. Probably about 60% of the money we've raised to date has come through his network. And Joe Probst, again, an entrepreneur, like me, a former director of engineering at Greatbatch, 13 patents. And I want to thank you for 43North for this, and ready for questions.
Nice job.
Thanks.
That was good. That was great, Glenn. $1.4 million per revenue per employee. We should all invest in companies that can do that. Okay, I'm going to start with some questions. And the first question I'm going to ask Bijan. Start the questioning for us, please.
Yeah, what's the biggest technical risk in this product? I mean, it seems like you've been working on it for 8 years. You know, I don't know what's the time to market at this point. It looks like you're shipping because revenue's kicking in next year. So what's been going on these 8 years, and what's the biggest technical risk still remaining?
Well, I don't think there's any technical risk remaining. We've beaten it down. 8 years ago, it was a concept. Since 8 years, we've actually built the machine. We've made the patents. We've proven that we've done the test results, and we can make these parts, you know, like by the millions. So it's really more just market risk and execution risk. We will be selling, our first purchase order is due by the end of January, 15,000 parts, and we take it off from there. Okay. That's, by the way, 25,000 parts per shift, one shift, you know. I mean, we got time to get it done in terms of on the floor, so.
Thank you.
Yeah. You know, trying to put that Buffalo Bills logo up there, trying to buy votes, I guess, huh?
Why not?
I like that. It was pretty smart, huh?
I'm older than her. I've known about the Bills a lot more than...
Okay. Esther.
So believe it or not, I'm on the board of a rocket ship company, and one of our big challenges is very finely machined parts. So I'm curious just a little more about the dynamics. If you need to change over to do a new part, how long does that take? At what volume? Like if we want only 5 of something, is it worth it? Can you just talk a little bit?
Sure. Well, in terms of the changeover of the parts, it's a tool die-based design. It takes about 15 minutes to just completely change the tooling. It's quick. As far as the low-volume parts, like in aerospace, they're going to want, we've already met with one aerospace company, they really like, their Skunk Works, they really like the fact that we can strengthen these materials greatly. I mean, this is unheard of.
And at low weight. And
at low weight, right. So titanium is a very strong metal. We pushed its strength up 33%, which is unheard of.
And how big can you make these
We're
things?
not, that's the limitation right now, probably about 6 inches long, 1.5 inches in diameter.
Okay.
So we're limited to that size. The next machine we make will probably actually be smaller to go after the abutments and some other components. But eventually we want to get to a bigger machine.
Okay, whether you win or not, I'll take your business card. Thank you.
Okay, thank you.
I have a question. Maybe I missed this in the presentation, but in the financials, so your numbers started to increase significantly when you put another machine online.
We show in year 3 hitting 12 million.
Right, but the financials are geared to putting another machine online, right?
They are. Yes, they are beginning in year 4, really.
Yeah. So why wouldn't you put machines online earlier, or is it just a question of resources?
It's a question of resources. Year 2, we show, in our plan, the way we show it, we show borrowing a little money in year 2 to build out the machine.
What's the cost to build out the machine?
That one's a small one, probably around $1.2 million.
Okay.
The first machine is about 2.5.
So if you had a ton of money, you could build a ton of machines.
We'd build 5 of them right in a row and kill that.
Got
yes.
It. Okay.
That's attractive, by the way, to me.
I think Esther's ready to give you a check.
David?
Any questions about durability, the molds, et cetera, the spring,
Yes.
any failure problems?
Well, no. There's a predecessor technology for cutoff, and the machines have run for billions of cycles.
Okay.
Very well designed. And the dies traditionally have lasted in cutoff for 10 million parts a piece.
And what are the dies made of?
Well, they have to be harder than the part you're forming. So if we're only forming carbon, we can get away with a copper, we can get away with a tool steel. If we're trying to form a tool steel or titanium, we're going to go to tungsten carbide.
Okay.
So, yeah.
Randall?
It's funny because I once wrote a story about a company called Crawford Fitting Company, which makes the swage lock. And so and the guy who invented that, Fred Lennon, became one of the 100 richest men in America. So the market I've seen, in reporting out is huge. So we don't doubt that. So you've been working on this for 8 years. Can you elaborate more on the patent protection? Because at the end of the day, if this is as good as you say it is, that's the key to everything.
That's
so, and you've had 8 years. So why aren't there more patents, and what's the patent status of all this?
Well, first of all, we had to develop it to the point where when you put the patent in it, you actually got the data to support it. The patent's pending. It's on a method to increase the strength of materials. That's the primary patent. We're going to be applying for some more patents again for with the winnings we have here. We'll be doing some more patent work for the controls and how we control the machine. That's very unique. We haven't told anybody how we do that. Very patentable. Beyond that, I don't think there'll be too many more patents, at least I can conceive of right now. But there'll be about 3 or 4 key patents that we get that'll protect it, we believe. Plus, there will be trade secrets. We want to keep some stuff trade secret.
Since we're on the stage just among us, so how do you do it?
How do we do what?
Just for nobody, we're just between us.
This is a public forum. Oh. So.
Does anybody else have any other questions? Kim?
Yes.
You forgot about me, Jordy. You said you were going to hire someone in business development. Can you explain a little bit more on maybe more details of what
sure,
you
sales.
think he would do?
Yeah, the
okay.
sales.
So you,
sales,
well,
sales
you were
and
having
marketing.
sales reps, but then you were going to hire a business. So is it just another salesperson, or is this someone maybe doing marketing, branding?
Yeah, all that. It'll be a person, experienced person that can coordinate all that, can build out the independent reps, and we'll start hiring some direct. We get a big account, you know, like let's say Boeing, you know, we're going to probably want to direct sell to them, not through an independent rep. So we're going to mix and match as we proceed. But I want to hire a person that's veteran, who really knows these markets, has got experience in them, and not his first rodeo.
Okay, and you don't have anybody right now?
No, we don't have anybody tagged for that position right now.
All right, so you have a job opening.
We do. We're recruiting. We're working with a recruiter that's right out here. Actually, Nick Beaver is global recruiting on that. So.
Are there any other positions that you're looking for besides?
Yeah, we're going to hire our. Right now, we've been using a couple of engineers on contract basis. So we're going to hire the controls engineer full time. That's the other key position we're going to hire.
Okay.
And so who is the rest of your team? You have 6 people now, or?
Total includes the two consulting engineers, myself, and admin, we've got Joe Probst has been working with us to get the machine up and going. That's the core team now. So, yeah, a couple of them we're going to hire full time.
So, Glenn,
Yes.
if you win the $1 million, what are we hiring? What's coming on? How many people are we bringing in?
Well, it'll be 6 by the end of next year. That's to get us going. But after that, it ramps up as the manufacturing builds out pretty quickly.
What kind of jobs?
About half of them will be on the floor. We're gonna create manufacturing cells and not be just a machine operator pushing a button. So they'll be doing their own inspection, their own materials flow, and we'll be able to pay them pretty well. We're looking for some, like I said, good paying manufacturing jobs returned to Buffalo from maybe been lost to offshore competition.
You have a place right now, correct?
Yeah, we do in Tonawanda.
In Tonawanda? How big is it?
About 5,000 square feet.
All right.
We don't need a lot of space. That machine is
Right.
so fast. It's a metal mover, you know. We want to look for a little bit bigger, maybe an 8,000 square foot facility to 10,000. But we can put a couple machines in there and just run them. And trucks coming in with metal, trucks leaving out with parts, you know. So.
We got a lot of space downtown Buffalo to bring you down here for, right?
That's right. We've been looking.
Anybody else?
Good job.
Glenn, great job.
Thank you very much.
Hold on a second. So that's our first. So how did it was it what you thought it would be?
This is a blast.
Yeah?
It's been better than I thought. I mean, the whole week, the 43 North, I got to really thank you and your team. It's been a blast.
Were you nervous?
Not really. Kind of made the pitch before a few times, but.
Yeah, but that's what happens when you have Keith, right? You know, you get drilled.
By the way, his folks, they honed it pretty nicely.
Good. Well, you did a great job. Thank you for being a part of this, and good luck today.
Thank you.
Thanks a lot.